Okay, so let's discuss a question on the epicyclic gear train. So we will do this by a table method. So, but before going to the table method, let's understand one thing. Like if you have two gears and their axis is fixed, so if this is moving with speed n1 and this moves with speed n2, angular velocities, and their teeths are t1, t2, T1 and T2. So let's say if N1 and T1 are given and T2 is given, how do you get N2? So this is actually, the bigger teeth will have, the larger number of teeth will have the larger radius, and that will move with the smaller speed. So basically NT is constant, okay. And to understand this, how we got directly is that the velocity at the tangential velocity at the interface is r omega, and that is same. So this r omega is basically constant, that is the pitch circle r radius, that another way of saying it is that the pitch circle diameter into the speed n is constant. And we know that the module is nothing but diameter by t. So if t is nothing but m into t, so t into n is also constant because module is constant for both. So t into n is also constant. So this is the indirect way of saying it. But the other physically, how do you understand is because the larger number of teeth means the bigger gear out of two gears, the bigger gear will have a larger number of teeth, and obviously it will move with a smaller speed. So nt is equal to constant. Okay. So how do you get n2? N2 T2 is N1 T1. So N1 T1 by N2 by T2. Okay, so this is the basic. And before going to the table, let's go to the table first. So table, what we do is we take arm, we take the sun gear, arm is C here, take the sun gear and the planet gear and the ring. Okay, and first what we do is, because it's epicyclic gear train, so the process is that first we fix the arm. We give X amount of rotations to the, or X is the RPM for the sun gear. So as the sun gear moves by X, the planet, going by this formula, the planet will move with X into, so N2 we want, so X into the teeth of the sun gear by teeth of the pin gear, and because X moves clockwise, so this pinion, this sun gear moves clockwise, so the pinion, the arm being fixed, remember that, imagine that arm being fixed, so when this moves clockwise, this will be moving anti-clockwise, so we put the minus sign also here. And when this moves anti-clockwise, the ring gear, because the planet is an internal gear to the ring gear, so ring gear also moves in the same direction. Like when you have two gears, okay, and one is inside it, so the inside one moves and the outer one also moves in the same direction. That you can easily understand. So if now this is N1, so N1 into T1, so pinion gear by N2, which is R. So now P and R is like N1 and N2. Okay, so this is the ring gear, and minus sign doesn't change because it's in the same direction of the ring gear moves in the same direction of pinion. Now we give Y rotation to the arm, so we just add Y to everything. Okay, and now the summing up will be Y X plus 5. So these are the total velocities. So Y minus X into TS by TP, and this is Y minus X into TS by TR. Okay. So now what is given is that the ring gear is fixed. So ring gear is fixed is Y minus X TS by TR is 0. Okay, and it is given that the number of teeth on the sun gear is 70, on the ring gear it's 100, it's 0. So Y is 7x by 10. Okay, now what is asked is, the question is velocity of the arm by sun gear, the ratio. So arm velocity is Y and sun gear is X plus Y. So Y by X plus Y, and so Y is nothing but 7x by 10, whereas X plus 7x by 10. So we just want to bring everything X in the numerator and denominator and cancel it. So 7 by 17 is the answer, and 7 by 17, if you just simplify, so this comes out to be 0.411. So the velocity ratio is 0.411. So this is simple. All the epicyclic gear problems are simple. You have to just build up a table and first freeze the arm, and so that everything moves with their centers fixed. Okay, and then just add the arm velocity. So this is again the philosophy of this epicyclic gear train, or this table method, is actually from the derivations. I mean, why we are doing this is basically from the derivation. So derivation says that you can just freeze the arm and calculate the speeds, and then just add the arm's velocity to everything. So this is per derivation, like why we are adding plus y to everything. So it's like first freeze the arm, get the rotations, and then imagine that arm is moving. So it's like providing rotations to every gear present in the system. So that is the thing. So it's simple to apply. Thank you.